Hey, Kelsey and Maya, this is the second half of the notes for section 5.3. We are doing all the formulas. You have these written down on your note card. I'm not adding any formulas to those note cards. We're just going through and doing the examples that go with them. Okay, so example 7 is going to be based off of that, probably based off of the annual, the top left, if you need to write that down. This is the top left equation on your note card. Okay, this is for annual compound interest. Annual compound interest, that's the formula that we're going to use for this next example. Here we go. Bacteria growth. At the beginning of an experiment, a culture contains 1,000 bacteria. Okay, shh. 1,000 bacteria. What is that?
You're starting.
What is, that's your P, that's your principal. P is 1,000, okay? As we go through these, label them as their certain variables so you don't have to go back through and reread. 5 hours later, what does that mean? Time is 5, and I'm gonna put hours next to it because most of the time time is in years, but make sure that you pay attention to what units they are and what units you're wanting, okay? There are 7,600 bacteria 5 hours later. What is that? After amount, 7,600. Okay, we're writing this stuff down so we don't have to reread. Assume that the bacteria grow exponentially. How many bacteria will there be after 24 hours? So I want to know time of 24 hours. What's happening? Okay, after a time of 24 hours, what is happening?
If that was in like days, would you just have to convert it to whatever to one?
What?
Or if your 2 times were different units.
Yes, correct. So if they would have said 2 days rather than 24 hours, converted to hours, because that's why I wrote it down over here, was just so that we pay attention to that. All right, now, what did they not give us?
Or the percent.
The interest rate. They didn't give us how much or how long it's doubling, tripling, whatever. They did not give us that. So we had to find that out by doing some things. So we know that our formula is going to look something like this. Let's plop them in and let's see what we have going on here now. Okay. After amount is 7,600 equals 1,000 is our principal. After 5 hours, it's doing something. Okay. So we've got something going on here, right? That's what we don't know. Really, it's kind of like 1 plus x, but I'm just going to leave it as x in here for right now. Okay, we don't know what that growth rate is. Can I solve this and figure out what x is?
You can divide by 1,000
okay.
and take the fifth root of
that is a really good idea. Let's divide by 1,000. Divide by 1,000. 7,600 divided by 1,000, just move the decimal. 7.6 equals x to the 5th power. And then we take the 5th root, like Mallory said. Okay, is this going to be really ugly decimal thing?
What do you do about the 1? Because there's like a 1.
Just wait. We're going to get to that. Okay, for right now, instead of putting 1 plus r, I'm just going to put x in there, and we'll see what happens. Okay?
Yeah, it's a straight cross. The answer would be 1.50024683.
Okay, give me 1.5 what?
0.
02? Okay, 1.50. Okay, we'll go 1.50. Okay, so
Sorry.
If that is what x is, what is r going to be?
2.5.
What's r?
1 plus? Or is it 1?
This guy is 1 plus r. What's r? 0.5. R is 0.5. What's our growth rate?
50%.
Our growth rate is 50%. Do you see how we did that?
Yeah.
Okay. We just figured that out. 1 plus whatever is that x, but I just called it x. Rather than dealing with 1 plus r, I just called it x. And now we're solving, and we subtracted 1, right? So 50% is our growth rate. All right, now that doesn't even answer the question. We want to know how many there are after 24 hours. So if our growth rate now we know is 50%, we can go ahead and just write the equation out, all right? So we don't know the after amount. It's not 7,600 anymore. We don't know after, but we do know we're still starting with 1,000. Our growth rate now, or our number inside of here, is 1.5, right? 1 plus 0.5 or 1.5. And we want to do to the 24th power, okay? How many do we have later?
So let's just solve.
After 5 hours, it becomes 7,600. And that's a pretty big increase. So after 24 hours, I'm guessing there's going to be a lot, right?
1,683,000.
Oh, hold on, 683 what?
It's
16,834,112.2.
4112.2. What?
Yes.
No.
So it's 16 million.
So it's
16
16
million.
million.
0.2.
16,834,112. 16,834,112.2 right there, like that. Okay. So 16 million. That's a lot of bacteria. But 24 hours later, it's going to be quite a bit, right? They keep multiplying, multiplying, multiplying. A lot of stuff. Okay. Next. Okay. Exponential decay. We're going to use this same formula that we just did. Okay, this is the formula that we just got done using. We're going to use the same thing, except there's one difference. You got to listen. Mallory, shh. There's one difference for exponential decay. What do you do?
No, it's 1 minus.
That's for radioactive decay, not the same thing. That's the next example. What do we do for decay that's different? Yeah, we change this to a minus instead. Right? So we're subtracting the interest rate rather than adding the interest rate. That's a decay function, okay? So, and this is just for regular decay. This is not exponential decay like what Sarah was saying. Exponential decay is this next one, all right? This is just for regular decay, like, oh, you drive a car off a lot and it decays or it depreciates at a rate of 5%, okay? Sometimes they'll use that. Depreciation. It's 1 minus R now instead, okay? All right, when tap water is filtered through a layer of charcoal, listen to this example. This is a good example. When it's filtered through a layer of charcoal, 30% of the chemical impurities in the water are removed. This is how they filter water, like the water purifiers, you know, they have like a chemical, they have a filter in there. Okay, it's a charcoal filter. And we do 30% of the impurities are gone now. Okay? That's if we filter it through one time. If we take that water now and filter it through again, is it going to be even more pure? Yeah. So a lot of those water filters, rather than doing just one layer of charcoal, they'll do 2 or 3, right? Because then your water will be very, very pure, right? If the water is filtered through a second purifying layer, 30% of the remaining impurities in the water are removed. So it's 30, 30, 30, 30, 30, depending on how many times you do it. How many layers are needed to ensure that 95% of the impurities are removed? Let's do this. Here we go. So, they don't give me a before and after. They don't give me a before and after. We have to kind of, in a sense, really make this up. Okay? So, let's do this. If we want 95% of the impurities to be removed, what do you want your before and after numbers to be? What do you want to start with?
1,000.
I'm going to start with 100.
So you're just
Start with 100? We start with 100? It doesn't matter. We get to pick random numbers, okay? And I'll show you why here in a second. If we start with 100 and 95% is removed, what's their after amount, right? 5. We get to choose those numbers just as long as they're in the relationship of 95 and 5, right? Does that make sense? Okay? So we're just going to choose random numbers. We could have chosen 1,050, right? Doesn't matter. How many layers are needed, okay? So what is how many layers? What are we solving for when it says how many layers?
T.
We're solving for time. Time in this case equals the number of layers. It's like how many times you're doing it. So number of layers is time. That's what we're solving for, right? Okay. Let's do after is 5. 1,000 is here, or 100 is here. 1 plus what's my interest rate? 0.3. Oh, but what? It's supposed to be minus because we're subtracting it out. So 1 minus 0.3. 1 minus 0.3 to the t power. Okay? 1 minus 0.3 to the t power. So let's simplify this just a little bit. Let's do this. 5 equals 100 times 0.7, really. Okay, because we're going to enter this into our calculator. Can you take 100 times 0.7?
It's trapped. It's gonna be.
Can you take 100 times 0.7?
It could be.
Yeah.
No, this one has an exponent. Do not ever multiply those two together because you cannot do it, right? That one's that. Okay, so here's what we're gonna do. I'm gonna flip over to my oh, I don't think it's gonna let me. I don't think it's gonna show it on my thing. We'll just have you guys do it. So what I want you to do is on your calculator, type in, go to the y equals, button on your calculator, clear out your stuff, and type in just 100 times 0.7 to the x power on your calculator under y equals. Okay, just go there.
Table.
Just go there. I'm gonna go see if I have a calculator back in my desk.
It doesn't
You
have
go
a
to
caret.
carrot, and then, oh wait, you have a fancy calculator.
It's the same thing. As ours.
Y
just-
equals
Why are you
100 times 0.7 to the x power. Ooh. Delete. To the x power. Okay, now where do you go from here?
The table.
Table. Let's go to the table button. Okay, second table, and it's going to plug numbers in. It's plugging in 0, 1, 2, 3, 4, 5, 6. We want it to get down to how much?
5.
5. So scroll down. Where does it get down to 5?
Right there.
Just a minute. Give me a minute.
16.807.
No,
What are
where
you
the
talking
Y is, where the
Where the y is 5.
Oh.
Where the y is
that's
5.
a long way.
8.3.
So somewhere between 8 and 9, right? I'm gonna put between.
Oh, 8.4.
What is your problem?
Between 8 and 9. Do you guys see where I'm at? Somewhere between 8 and 9 is where it gets down to 5. Okay. Now I want to get closer than 8.
So you go second.
So now we go
then
to second window,
you go point.
It's between
0,
8.4
and we change our window to change. We're gonna start at 8, and we're gonna go by 0.1s now instead, and go to your table again.
8.3 and 8.4.
I'm gonna say start at 8. Change table equals 0.1. Your change in your table is gonna be 0.1, and then we're gonna scroll down. We're gonna go to our table again. Where does it switch between? I didn't do it right.
8.39 and 8.4.
Oh, 0.1, not -1. 0.1. Ah, no, quit it. There we go. Okay, in between, what did you say? In between 8.3 and 8.4.
What?
Will you make that face again?
Did she do this little thing?
Yeah, that.
Which one's closer? 8.3 is at 5.18 and 8.4 is at 4.99.
8.4.
Jellyfish launcher?
So 8.4. What does that mean? How many layers do we need?
8
No.
and a half.
They're not going to do a half a layer. How many layers in order to ensure if we do 8 layers?
9.
If we do 8 layers, is that going to remove 95%? No. If we do 9, what percent is it going to be?
Like 98.
Probably 98, but that's our only option. So we have to do 9 layers. Because in this case, we always round up. Okay, you people watching this video, this probably didn't make a whole lot of sense to you. We did this in class the other day, but if that doesn't make sense, come see me. Okay, 9 layers is how many we need, yeah?
Yep.
Okay, exponential decay or radioactive decay. You guys have a formula on your sheet. This is the bottom right formula, okay? I think did we write it as 0.5? Maybe Gracie wrote it as 1/2, right?
I wrote it as half.
Okay, and they do x over h. It's the same thing as t over h. What does h stand for in the formula?
Half-life.
Half-life. So everything has its own half-life. Like here is carbon-14. I said 5730 years. That's the half-life, all right? Let's write this out. When an organism dies, its carbon-14 decays exponentially. An archaeologist determines that the skeleton of a mastodon, I looked this up one year, a mastodon is like a sea, it kind of looks like a sea elephant is what a mastodon. No, is that what it is? Mastodon.
I'm gonna look
A manatee?
No.
That's a sea cow.
No, that's a sea cow. It was something else.
It's a sea
Mastodon. It's like a mammoth.
A sea mammoth?
No, it's not a sea
Oh,
mammoth.
it's just a
I was thinking of something else.
Dude.
It's just a what? Did you look it up?
Just a normal mammal.
It's just a normal mammoth. So a mastodon is a mammoth. Has lost 64% of its carbon-14.
I want a mammoth.
Okay. When we're doing radioactive decay, we need an A, we need a P, we need a T, and we need an H. Those are the things that we need for radioactive decay. Okay?
We don't know.
Okay, what we don't know?
Hey.
Estimate how long. We don't know what T is. We don't know how long the time has been. Do we know H?
Oh, what are you
Half-life is
doing?
5,730.
5730. Okay? A and P. This is the tricky part. They don't give us an A and they don't give us a P, but they do say 64% has gone.
We can do
I don't know what he's doing.
136.
You gotta listen. Cray, why do we use 136? 100 for P and 36 for A. Why?
Well, you see, 100 is because of the percent.
Sure.
It's the maximum.
Okay. Sure. Right. Okay. I gotcha. Okay. Now what? Oh, where do we get 36 from?
That's. Oh, no.
We're making up those numbers, right? We could have made up any numbers, but if we know that 64, Cray, stay with me.
Yeah.
If we know that 64% has decayed, and we start with 100,
100 minus 64.
there you go. 100 minus 64 is 36. Okay, now here's my question to you. Have we split in half?
What?
Have we split in half?
No.
No.
Yes, over.
Or yeah.
We've split in half, right? 100 is now becoming 36. Have we split in half?
Yep.
Yes, we've more than split in half. So this is going to be more than,
1.
what?
I don't know.
57.
How many years has elapsed?
More than
More than 5,730 years, right? We know because he's already split in half once, right? He's already split in half, so we know it's more than 5730 years. All right, let's plug stuff in and let's see what we get. 36 is my after amount. 100 is my beginning amount.
2.5.
And we want 0.5 to the
X over 5730.
T over 5730. This is another one we're going to plug into our calculator and we're going to figure stuff out, right?
That is disgusting.
How
It
do you
is really
plug
gross.
in if you have an answer?
Okay? Like we just did.
No,
We had an
you
answer
have-
here.
You
We had
just
5
forget
here.
all
Put it in
You
the
forget
y
the answer.
equals.
So we're just going to go into y equals. We're going to type in 100 times 0.5 to the T over, or you're going to do X, over 5730. Type that in and see what you get. Okay, you might have to go back to your table set
Oh.
and change it back to by ones, right?
Oh.
Start at what?
Start at, what do you want to start at? We know that it's going to be more than
57.
5730. So in your table set, it would be a really good idea to start at, and I'm going to start at 6,000 and go by ones. Can we do that?
Smart cookie.
And we want it beneath 36.
Yeah, what are we looking for?
I just want to die. Go to like
Oh, that's why.
7,000.
Yeah.
Start at 7,000?
Yeah.
Yeah.
Because we want it to be what, 36? Yeah, it's really
Yeah, maybe 8,000.
8,000.
No, go to 7,500.
No,
Did
it
you do
still
it?
hasn't gone down that far. I'm at 8030, and we're still going.
Oh, it's right around 8,500. Hold on.
Start at 8050.
Higher than that. I'm gonna find it in a second.
What do we want? 36.
Between
Go to-
84.45 and 84.46.
Okay, 8445 and 8446. I'm gonna go to second table set. I'm gonna start at 8445. Yep, there it is. 8445 and 8446. Yeah. 8445 and 8446. Holy cow, that's a lot. That's a lot. So, estimate how long ago the mastodon died.
8,000.
Which one is closer? This one is 36.003.
8446.
This one's 35.998. Which one's closer?
8446.
8446. So what does that mean?
That's how long ago it died.
Years ago. The mastodon died about that many years ago. Okay?
These are painful hiccups.
That's a long time.
Hey, we're done. I need to bone in.
Confusion?
Yeah.
Are we okay?
Yes.
Yes.
Okay. You guys should have the majority of 5-3 done. The back side is all that you, 9 and 10, you know how to do now?
Yeah.
So do all of those for homework. That is your task.
We're about to
Use your time to work.
Mhm.
Use your time to work. Goodbye, people in the video.
Out of there.